Currently, rods are outsourced to another company to have threads cut on a Swiss lathe. Sometimes that company has long lead times that hinder production at TNT Tools. An in-house method to cut threads would be used during periods of long lead times to increase production. Some of the constraints and specifications of the project were that the machine must be able to automatically thread 3/8 inch and 7/8 inch long 3/8 24 UNF 2A threads onto 3/8 inch diameter rods. An optional specification was for the machine to thread 15/16 inch long 1/2 13 UNCA threads onto 1/2 inch diameter rods. The machine must be powered by either 120 volt, 240 volt three-phase power or 480, 460 volt three-phase power. The machine must meet safety standards, both mechanical and electrical. Any pneumatic component used must operate with a 90 psi air supply, and the machine must be movable with a forklift. The method used for forming threads is a geometric-style, self-opening die head that uses chasers for cutting threads. When the desired thread length is reached, the front of the die head rotates and the chasers expand. The die head then needs to be rotated with the handle to reset for the next cut, as seen in the current demonstration. In this video, a prototype will be demonstrated. The rod is first loaded up against a hard stop and then secured in the chuck. The die head is secured in the lathe's tailstock. Once the spindle is turned on, the die head and tailstock is moved into position. The die head's chasers then begin cutting.
And we're threading.
Once the desired thread length is reached, the die head rotates and expands. The thread is now cut into the rod. Throughout the course of the project, a number of challenges were faced. One example was supply chain issues. Over a dozen components ordered through our primary vendor had lead times longer than 4 months. Alternate vendors needed to be found, but even some of those had similar lead times. Another challenge came with retrofitting the electrical systems of a used lathe. The electrical system could not be finalized until a specific lathe had been chosen, but even the chosen lathe presented unforeseen issues once we started dissecting the electrical system. The final challenge was electrical and controls engineering issues. All 4 group members are mechanical engineers who had limited experience with electrical circuits and virtually no experience with controls engineering prior to the project. This knowledge had to be learned during the course of the project by taking classes and consulting with professors.